For this lesson, we're going to take a look at the expanded version of multiplying radicals from what we've done in the past. So the first thing, if I'm using the distributive law to expand the following, well, I'm going to multiply the 4 into the x and the 4 into the 8, which is going to give me 4x plus 32. I'll do the same thing in the second set. I'm going to do the negative 2x into the 3x and negative 2x into the negative 5. This is going to give me negative 6x squared, and the negative and negative will cancel out and give me positive 10x. If I am foiling these things out, then I'm going to multiply the first terms, the outside terms, the inside terms, and the last two terms. So the first terms are going to give me x and 2x squared. Then the x and the 1 is going to give me plus x, 6 and 2x is going to give me plus 12x, and 6 and 1 is going to give me plus 6. And then I just combine the like terms to get 2x squared plus 13x plus 6. For example B, I would do the same thing. So I'm going to FOIL this out first and say that this is going to give me, we'll have a 5 on the outside, and when I multiply these out, 8x squared plus 14x minus 12x and minus 21. I can multiply everything by 5, and I'm going to get 40x squared plus 70x minus 60x minus 105. And I can combine those like terms in the middle. This is going to give me 40x squared plus 10x minus 105. If I'm multiplying radicals, well, if I have the square root of 3 times the square root of 5, is that going to be the same as the square root of 15? This is true. I'm just multiplying the radicands. Square root of 2 and the square root of 6 equals square root of 12. This is also true. If I have 6 and the square root of 2 times 4 and the square root of 3, does it equal 24 and the square root of 6? Yeah. If I have the square root of 2 and the cube root of 5, does this equal the 6th root of 10? No, that's not the same. 2 root 5, negative 4 root 3, does it equal negative 8 root 15? That's true. And 3 in the cube root of 5 times the cube root of 6 equals 3 in the cube root of 30. This is also true. So, based on what we see from A to F, write a rule which describes the process of multiplying. So, radicals with the same index can be multiplied. Multiply the coefficients. And multiply the radicands. We can see this with examples C, E, and D. If I multiply the 6 and the 4, that's where I get the 24. If I multiply the 2 and the 3, that's where I get the 6. If I multiply the 2 and negative 4, I get negative 8, and 5 and 3 give me 15. Or 3 just becomes 3, and the 5 and 6 become 30. So, we always multiply the numerical coefficients by numerical coefficients. We multiply the radicand by the radicand. And then, if possible, we're just going to simplify the radical. So, for example, A, root 5 and root 2. Well, 5 times 2 is going to give me root 10, and that can't be simplified any further. Root 6 and root 6 will be the same as root 36, and the square root of 36 is just 6. If I have 2 root 5 and 4 root 6, the 2 and the 4 are going to give me 8, and the 5 and the 6 are going to give me root 30. If I have negative 5 and positive 3, that's going to give me negative 15. 3 and 3 are going to give me square root of 9. Well, the square root of 9 is just 3, so this would be negative 15. And 3 is a simplified version of that, or negative 45 when I multiply them out. For example, E, if I have 4 root 5 squared, remember that's the same as 4 root 5 times 4 root 5. I square the outside, 4 times 4 is 16, square the inside. 5 times 5 is 25. This would give me 16, and the square root of 25 is just 5, or 80. And if I have negative 7 root 3 times negative 7 root 7, multiply the outside, multiply the radicands, negative 7 give me positive 49, and the square root of 3 times 7 is 21, and that can't get simplified any further. Now, if I have variables, I'm following basically the same process. X times x is just going to be x squared. The square root of x squared is actually just x. 8 times 9 is going to be 72, and the square root of 8 times a is a squared, and the square root of a squared is just a. 2 times 5 is going to give me 10, and x times y is just xy, and that can't get simplified. Michaela and Richard are determining the radical product of 2 root 8 and 5 root 12. Michaela multiplies the coefficients and multiplies the radicands and then converts to simplest form. So she's starting with taking the 2 root 8 times the 5 root 12. 2 times 5 is going to give me 10. And 8 times 12 is going to give me 96. And from there, she's going to simplify this. Well, 96 is going to split into 2 and 48, 2 and 24, 2 and 12, 2 and 6, and then 6 is going to split up into 2 and 3. I got the 2 2's, another set of 2 2's, and then a 2 and 3, which are left by themselves. So, this would be the same as 10 times 2 times 2 times the square root of 2 times 3. Or 40 root 6. Richard converts each of the radicals into the simplest mixed radical and then determines the product. So he started with 2 root 8 and 5 root 12. And then he's going to convert the 2 root 8. And that's going to give me 2 and 4, 2 and 2. Or 2 times 2 times the square root of 2, 4 root 2. When he does it for the 12, I get 2 and 6 and 2 and 3. Got 2 2s and a 3 that's left by itself. And I had a 5 on the outside there, so it's going to be 5 times 2 times square root of 3, or 10 root 3. And then he multiplies it. 4 times 10 is going to give me 40, and 2 times 3 is going to give me root 6. Now, the main reason why many people find it easier to simplify the radical and then multiply is because multiplying smaller numbers and then having to simplify at this point, or simplifying the 8 and the 12, a lot of people find easier than simplifying the square root of 96, but there is no right or wrong method. Whichever one you are more comfortable with is the right way to go.